Are we live?
It should show in a few. Yeah, it's showing join now.
Mhm.
Everything is live.
Are we live?
Awesome. Okay, great. Wonderful. I am so excited to actually kickstart with my wonderful colleagues here this workshop series about energy AI or energy and AI. How do you apply fundamentally uh, groundbreaking but also conventional deep learning and machine learning algorithms in the field of energy? With me, I have my colleagues, Tanishta, who is our head of engineering from joining from Toronto, and we have Qamar Naseem, a senior AI researcher from IIT Kharagpur in India. So this is an introduction section session. So we are going to give you a little bit of a walkthrough of, uh, what are we going to talk about in the coming webinar series, how the structure will look like, and there is a small presentation, and we really encourage you to also participate in this discussion because our goal is to bring all that cutting edge work that we are doing also to the audience through the means of GitHub, but also one-on-one conversations. So just to give you a brief introduction of my colleagues, Tanishta has been leading engineering and software development and overall sort of managing portfolio of the projects that we do for our customers around the world, and there's a lot of learning that goes into understanding how to take models, how to try to conceptualize these into good looking user interfaces, but also making them efficient so the customers can actually have the same experience, but as an end user, not as a researcher. Now, when it comes to research, Kwame obviously goes extremely deep. Now, in this specific case, it's a pun intended, because in this case we're going to be talking about energy for oil and gas operations, where you go literally deep, uh, close to 3,000 kilometers, 3,000 meters. My apologies. Uh, and understanding the subsurface to help oil and gas players. But we're going to be talking about a lot of other fields as well, and how we are using cutting edge AI research to bring these you know complex algorithms and models that we develop in easy to understand, in very very easy to use manner, so customers can use them as part of their day-to-day operations, almost literally like using your Word document or some other simple application that you have. So that's our goal. It's a very ambitious goal, but we believe in bringing these complex solutions to the market. So that's a bit of an introduction of my colleagues. Maybe Tanishta, very quickly about yourself and Kwame, so the audience gets to know you, because I know you guys will be running this series. My job is to help you facilitate with conversations with all the people who will participate in this. So go ahead.
Yeah, sure. Hi, everyone. I'm really glad that you all can join us and kickstart this webinar series. I hope this is really beneficial to everyone using deep learning, but also who are interested or who are actually working on energy industry, conventional as well as renewable and so on. Brief about myself, even though I'll go through this in PPT also, but a brief is I do have a background in geophysics, had a PhD in geophysics a while ago, but my main research or my main interest really lie how you can bring all these AI applications into energy field, because energy is definitely a very fascinating field, and while you can automate a lot of steps, it's still not there as we speak of NLP or any other industry. But it's what we are really fascinated about, to just go ahead and use deep learning in these domains. So Kwame, you can take over.
Hi everyone, thank you for joining today. So I'm Kamar, I'm from India, and as Terry already mentioned that I am a senior AI researcher at Deep Kappa, and mostly my I am actually currently doing my PhD, and I have a background in geology and geophysics, and my main area of expertise lies in integrating geoscience or basically energy domain with AI. And as you know that in energy domain there are like lots and lots of uncertainties, and due to which there's lot at risk. So my main goal is to minimize those risks and increase the profit margin of a company. So that's what my main objective is. Yeah.
Thanks, Kwame. Maybe we have prepared a slide. This is like an introductory section, and we'll go through what you can expect in those next upcoming webinars. We also have created a GitHub, which is free, and everyone can access that. I also hope that it becomes a really interactive session because we also want to know what are your pain points, where you are really achieving things. So please go ahead and stop us for any kind of question or anything. I will just appreciate that. So maybe I'll just go with our presentation here. Okay. So as we mentioned, this is a guide to deep learning applications in energy. So for now, we will actually give you some examples in conventional, and later on we'll be also moving into renewable energies. Like there's a lot of fascinating fields over here. Definitely, if any one of you have anything to add, like want to talk about some other domains, that's good enough. We'll also kind of accommodate that in our coming webinars. So what you can definitely expect is it is actually for anyone who is a seasoned player or who is just starting out. I hope you both anyone can enjoy this because the way we have structured it is that we are going through coding from scratch. We'll also explain different concepts such as transformer, loss functions, and so on. Everything will be on our GitHub, and I hope that it helps brings some good information, good knowledge to all of you in joining the webinar. So maybe we can just go a little bit why AI is important in energy. AI is important anywhere, as you can know, whoever is joining this webinar, you know AI is definitely important at this point. So how can it help really in the energy industry? It increases customer engagement. It can help in grid management and efficiency. AI is also the driving force, the intelligent agent behind any smart grids. Smart grids, as you know, is a concept that is really like evolving these days with any kind of. This is more on a renewable energy term, but this is AI has been driving it a lot. It also can provide detection of power theft, energy fraud, and so on. One of the very good applications of AI is it can do predictive analysis and help in energy trading, energy storage, and so on, which is also quite developing in this era. So the speakers for today is me, Danishta, and Kwame, and also we have Terry. So as we mentioned, we are really passionate geologist, but at the same time, we want to bring all the aspects of artificial intelligence to this subsurface business. As a little bit about myself, have a PhD in geophysics. I did work in upstream oil and gas industries. However, I am really happy to be here at DIFCAFA and working on cutting edge technologies and implementing this into oil and gas projects. I can also call myself jack of all trades because I've been also working. I did work from subsurface, surface to subsurface, even into like deep earth, such as mantle, core, and all. And I do feel that at this point, especially what happened in Turkey and Syria, I think on Monday, it's really important to apply AI into early detection of earthquake, so you can save a lot of lives, right? So I'll hand it over to Kwame, who'll take over now. Kwame, can
Yeah.
you begin?
Yeah. So hi guys again. Hi again. So as I already mentioned that my area of expertise lies in integrating energy domain with AI and maximizing the profit and minimizing the loss and risk of a company. And we have actually worked on many projects at Deep Kappa. I personally have worked on that, and I mean we were able to successfully minimize those risks, and for which we will be talking further in this webinar and coming webinars. So can you move to the next slide, Tanishta?
Yeah.
Yeah, okay. So for any cutting edge technology to succeed in real world, I mean it must focus for sustainable operation innovation. So and this can only be achieved with these four elements that you see: research, business, product, and technology. So first we need to address a question that whether this is, I mean, first we need to do research, and whether is it possible, does it make sense to do this particular research. And once we have answered that question, then I mean we will obviously move to the technological side of it, whether it is feasible, whether it is technologically feasible or not. And once we have established that, then we will look into product viability. Can we make a wonderful product out of that? And I mean, can we make a good interface uh, so that the interface is user friendly, and I mean whether or not user will is going to like it. So we do all sort of analysis over there. And then finally the business side of it comes, whether or not, I mean, is it profitable business or not. So combining all these four elements, we this at the heart of this at the heart of any enterprises, combining all these four elements, this is basically the operational innovation that we have. Can you
Yeah,
move to the
so yeah, as I was mentioning, so it's with this four circles over here, as you can see. So if you belong to any of these, or even if you are lying at any intersection, I believe that this webinar will be helpful, because it's not only that we'll be us talking about research, technology, product, but also business, and then how do you get into operational innovation with all these four components. Yeah, Kwame, you can go ahead.
Yeah, I
So
mean, so
yeah,
go
okay,
ahead.
cool. Yeah, so
Okay.
we actually arranged for some trivia questions. So for audience engagement, yeah, Kwame, you can take that
Yeah, I
question.
mean, so I mean, the first trivia question that we have is like neural networks can be used in a regression problem, clustering problem, classification problem, or all of these. Maybe you guys can put out on the comments if you guys can put.
Terry, can people comment on
Yes,
the?
people can comment. Go ahead and comment. It's obviously it's just to get you guys a bit excited. There's no pressure. There are mostly no absolute right answers, but of course, please participate. If not, we'll keep sort of adding some more fun stuff. Go ahead.
Yeah.
Yeah,
Okay. So can you go to the next slide?
Daksh
yeah,
has an. Is this
huh?
the right answer?
Yes, that is
Okay,
correct. Yeah.
wonderful, Daksh.
Okay, yes.
So yeah, I mean, with regression problem, we normally try to predict a real value, whereas in classification problem, we try to classify between different classes. And in, I mean, in clustering problems, there is a technique called self-organizing maps (SOM), which is actually used in neural network to cluster all the basically the input data that we have. So yeah, basically it's all correct. Can you? Okay.
Yeah. Okay, so I can take over the agenda. Today's webinar is just a kickoff. So we'll just keep it very simple. So we'll just touch base on what's the present state of AI. So application of deep learning in some domains of geoscience. At this present seminar, we'll just talk about that. But there is definitely other applications in renewable, as I mentioned. Then how automation is helping the oil and gas industries. Here we'll kind of touch base on what the giants are doing, such as Schlumberger, Halliburton, and so on. Then we'll also discuss what are the offerings, how is this webinar benefiting. We'll go through our GitHub and we'll actually try to, we'll also show you where our notebooks are, and we'll keep adding all these notebooks as well as the videos and the presentation as as these webinars proceed. And then we'll take a use case of well-to-well correlation. You don't have to be a geologist to know this. We picked up this because this have lot of complex concepts, like where you can apply a lot of deep learning, like in can build various pipelines to achieve this. So we'll just talk about how this physical problem is, and you don't have to be a geologist for it, for this, for it. So maybe coming to this first point, so AI automation is already happening. We all know their common benefits are improved operational efficiency. Then it reduces time, effort, cost, while also using manual errors. Very common examples of what AI is doing. You can also take over AI, taking over repetitive tasks, and it's completing it faster, improving its quality, consistency, also increasing employee satisfaction. Very important, also increasing the customer satisfaction. So over here, I just put some examples in terms of how it is helping geoscience, but there's a lot, right? So the paper, if you see here, this excerpt is seismic phases analysis. This is where we started our Earth Scan organization, basically. So this is a paper which is where we actually developed an in-house algorithm, Earth AdaptNet. If you can see the architecture over there, and it has been doing a wonderful job of actually identifying seismic phases. So seismic phases is mostly a very complex analysis that goes into categorizing the subsurface, because that's how you can identify what kind of rocks are there, if it has oil or gas or water and things like that. Then over here, I did pick this from a paper. I don't remember. So it talks about P and S wave, and it's actually trying to detect early detection of earthquakes. Of course, that is really becoming important these days. And with backdated technologies, it was not possible. And with a few of these papers that we have been seeing, it's really making quite good accuracy on the prediction of earthquakes. Also did put a transformer model here because we did develop recently also an in-house algorithm that is called PeerNet, which is based on this transformer models. And over the course of this webinar also, we'll touch a few elements of transformer and like hierarchy and loss function and things like that. Then maybe this is more is carded most to oil and gas, but you all know about Schlumberger, Halliburton mostly. So Schlumberger has been actually has partnered out with Data IQ, and they are being really using AI solutions into their upstream work. So, like if you know about seismic processing time, it's they have slashed it down from 13 months to 2.5 months. There was actually one of the very tedious tasks that happens in the oil and gas industry and very expensive, which have definitely been developed here. Fault interpretation also time down to 80%. So also fault interpretation is very important when it comes to oil and gas. What do I say? Exploration. Well planning. This is also very important when you are drilling. That is in the production phase. Halliburton, they also have launched a DS 365 AI, and which is actually where they're also using AI in drilling and production. And definitely they also see a lot of improvement. They have saving millions of dollars in 60 wells. I think this is data from a well in Middle East. So just to show you how really AI is helping already the oil and gas industries, but there is a lot to discover yet and lot to automate in this energy industry. So time for a trivia question two. So what of the following is not supervised learning? So it's answer. So the options are PCA, decision tree, linear regression, and naive Bayesian. So I'll just give about a minute time. Okay. So the answer is PCA. Um, hello. I hope everyone is able to see the screen. Okay, I'll just stop sharing. Ye- Is
Yeah,
it visible? Yeah. Okay.
it's
I
visible.
thought that it was just frozen. Okay. Sounds good. So now we'll go into the offering. So GitHub. Let me just get out of this screen. Stop sharing this, and I will move into. I'll show you the GitHub first. Okay. So we have also provided the link of this GitHub in the or in LinkedIn. However, this is how we are kind of. This is all the we have put like the tentative webinar series, like the next webinars that will be coming up. We have shared. We'll keep on putting all the notebooks here. This week we are not going to go into any notebook description, but you can see that it's just taking some time to load. But we'll be putting out these notebooks. So also there is you can actually you'll have the access to data to run this notebook. So I encourage all to run this notebook, and if you get into trouble, you can also reach us. And if you think that this things can be improved or better, you like improved, just let us know also. But this is how all these notebooks will be there. But in the subsequent webinars, we'll actually be going through like tutorial, like going through all these notebooks, and so you can understand and ask questions. Um, so maybe we'll go back. Stop sharing. I'll go back. Okay. Okay. So what you get out of this webinar is entire access to the GitHub, where you also have these webinars recorded, and like the presentations will be also there. So what we try to do over these notebooks is that we'll demonstrate the workflow, like how the pipelines are created, and then also in the presentations we'll run through a few concepts, transformers, laws, functions, and things like that, where you can have an idea how what that is. Many of you might already know that, but we'll just kind of brush up on those ideas, on those tasks and ideas. And then this is a well-to-well correlation. As I mentioned, this is just a problem that we picked only for running a lot of concepts to this. So I'll ask Kwame if you can just go through this presentation.
Yeah. So as Tanisha mentioned that, I mean, this basically is one of the example that we will be showing, and in the coming in the coming webinars as well, we will be picking on this uh, topic. So basically, this is a well-to-well correlation problem, and I mean, to define you what the problem statement is, I mean, and I will try to define it as layman way as possible. Is there are several layerings within Earth. So I mean, if you want to correlate one well with another
Yeah,
well.
so maybe Kwame, we can just mention these curves, right? So
Yeah,
there's
sure.
different curves, yes, which shows you different signatures. So these are though the header is not there. For example, this can be gamma ray,
Right.
which yeah. So gamma ray resistivity, even like sound, right? VPVS. So all these physical properties, kind of when it goes to the earth, it gives a different signature based on what kind of geology or lithology kind of you have there, maybe rocks, or if there is presence of water or oil, so the signature changes. Okay, so you see there, this is how these different sections, this is a very simple PCA done on these sections, and even with a PCA you can see that you can cluster these sections, right? That these are these kind of rock. Yeah, Kwame, go ahead. I just wanted to explain this figure.
Yeah. So basically, I mean, at the end of the day, what you would want is you want to correlate one well with another well. And I mean, that could be correlation of anything. I mean, here in this particular problem, we are trying to correlate something called stratigraphic correlation. Tanisha, can you maybe go back to the last slide? Itself? Yeah, so here what I mean I'll so here what we did is you see there are these lines or these logs that you see, and uh, basically these are the signatures, and these have information on where those classes would change, or where those correlation pattern, basically we see this pattern and we try to match it with another well, or basically another well. So what are we have actually tried many different ways to improve the model, and one of the ways was to because here in any geoscience or energy domain, the data set is of like shortage. I mean, there is not much of a data set available, so we had to rely on data augmentation, and apart from that, we also tried to get model pre model pre-tuning, so as to basically if we do a autoencoder way of model pre-training, then the model already knows what feature to look into. And apart from that, so the whole workflow works like we first try to identify the kinks. Basically what that kink would be is
Yeah,
if
kink
you
would be those regions, right? Yeah. So where you these are kinks basically.
wherever there
So
is a transition
yeah.
between two classes, that's what we call it kink. So first in the first phase of model training, we try to predict these kink points, and after that, once we have trained our this kink point model, then what we would do is there will be a reference well and there will be a test well.
Yeah.
So
So
we
for
will
example, if you have maybe have
this
yeah, you
particular
have well and well one and well three. You know information from well one and well three, but you don't know anything in between, right? So how do you get this information? So this is how. So with those with our deep learning algorithms, you can get information of this. So this is the way these data arrive is not really images, but they are more like tabular data. Also a lot of missing data, a lot of erroneous data and things like that, so it needs a lot of cleaning and all. So but one of the things that geologists and geophysicists are interested is what lies in between. So with in like traditionally what they do is like look at all these and then try to do a kriging method and things like that. But here we can will go into really the concepts of deep learning to use this, and this will definitely be a very good improvement on what happens in traditional way. Yeah, Kwame, do you have to add anything else?
Yeah, so I mean, as I was mentioning, that we first train our king point model, and after that we use this. I mean, if you consider well one as reference well and well two as the test well, so we find the king point from here, and then in this test well, and basically we try to
Yeah,
find the
so
correlation
these are
between
king
these
points. Yeah.
signatures that you see of this. Let's say this is gamma ray, so you try to find the signature pattern that matches from the reference well to the test well, and then using that we assign a particular zone that same class, so that way we populate this whole well with this with the top information, or the correlate basically the correlation information. And that's what we do. In the next webinar we will be going deeper into this.
Yeah, we'll look into the data set. Once we will show the data set. I think we have a link of that data set also, right, in the GitHub already, right?
Yes, I guess,
Yeah.
yeah.
Yes,
Yes,
we
there
did.
is.
Put,
I have
yeah.
provided
So
the.
if you have a want to look, take a look. It's quite messy, and that's what you have to. We have to do a lot of data cleaning. So that's and data augmentation too, as Kwame mentioned. So that's time for trivia question three. Kwame, do you want to take this?
Yeah, sure. So, I mean, there are actually many ways to determine the similarity between two things. I mean, taking an example of the previous use case, I mentioned that we are going to find the pattern from reference well to the test well. So there is a similarity score that we are looking out there, and it is actually something related to that. So there are many ways to determine this similarity between two things, or you can say two curves. So in order to represent that similarity in machine, we need to have some score, and which out of all these four is correct answer. So I mean, there is Euclidean distance, then there is Pearson coefficient, and then there is cosine similarity. So which among these do you guys think is used as the similarity score? Do you guys have an answer? You guys can comment. Think we can
Yeah.
move on.
Okay. Yeah, we'll touch on this, especially similarity score. I think we'll talk about it also. So the answer is like all of the. Oops, sorry, it's actually all of the above, not
Yeah,
it's
I
all of
think
the above.
it's.
It just missed, yeah, but it's all of the above. So you can do a similarity score based on any of these. Um, so
Yeah,
so now we can take some Q&A. Also, just putting out there the GitHub link, and you can connect with me. Just put over in the comment section. I can also put my email, but it's also there in the GitHub. So I'll stop sharing and let's have some discussion questions.
Yeah, I think, guys. First of all, thanks, Tanishta and Kwame. I know when there's a lot of hype, as you all know, especially around all these generative AI, specifically around text generation tools that are being launched. And I was also kind of some researchers were also getting a bit pissed when I was sharing maybe a bit too much about ChatGPT. But I just wanted to actually explain the underlying tone of why I think it's important for us to look at these innovations. Maybe a better way for you to explain to you guys, which we will also share with you guys in the coming months and weeks and months, is that the foundation of all these tools that you will see on whether Microsoft Bing or inside your Teams collaboration tools or any other form of productivity enhancement through these algorithms is all based on transformers. So in the coming webinars, maybe I will go a little bit deep dive into explaining about sort of the language models. Many folks don't know that we have our own also training platform, which we have actually sort of now we are focusing only on uh, teaching our own team. So initially we had launched it. I can show you guys. Perhaps that gives you a bit of an idea that we do a lot of things, and there's a lot of modesty around most all of my team members except me. You will see me going a little bit brash in explaining about a lot of things. But actually, my goal is to give you the underlying picture. For example, uh, I can share the screen about our training program. For example, here we have trained folks on various AI. Energy is also definitely a very important aspect where we teach people about both computer vision and transformer based models. And this is the team. You see Tanishta, myself here as well, and Kwame, and the whole team members are there. We've trained, at least 27,000 people in the last few years. So there's a lot of learning that goes into building these platforms. And it might surprise you that transformers are used in many industrial applications already, and we are pioneering those as well ourselves. And those architectures and models, etc., will come in the coming webinars as well. So I just want you guys to know that while it seems like a very narrow theme that we want to talk about, which is about energy sector and perhaps a domain which geologists, geophysicists, or geoscientists understand more. And but I think what you're seeing is that large companies, service companies like Halliburton, Schlumberger, Baker Hughes, they're all creating large AI labs. So when you learn these skills together with us, you will also get an idea of looking at complex problems through the eyes of a data scientist. And given that these companies are investing large amount of capital, it will create opportunities for you guys to also start actually practicing your machine learning and deep learning skills in these domains. So I will not go deep into explaining about language models. There are many programs that are launching to help people understand and improve language models. And we are also going to be deploying these into industrial applications, allowing geologists to actually run scripts for certain minor operations. For example, I shared a paper just a few minutes ago around digitization of a value stream, which is taking a well log. All those things can further be hyper automated when you start using a language model to say to a language model, do this, this, and this. Now, if you're able to plug your custom algorithms and systems within inside your own industrial domain. Now, just think in terms of how Andrew Ng, and I love Andrew Ng, he's probably the best person to my. This is my personal bias towards Andrew because Andrew has gone into a very complex industries, manufacturing, with his startup Landing AI, and it's all about small data. So if you're able to literally plug the learning from transformer models and then attach it to small data using reinforcement learning, human feedback loop, you can actually create extremely productive applications. And that is the future in the next 2 to 3 years, which we will be building with EarthScan. EarthScan, I didn't talk much about it. Is a startup which we are going to be launching very soon. And there's a ton of innovation that actually has happened there. And Kwame and Tanishta and several other researchers who we hope to introduce you guys in the coming weeks, you will get to learn. So obviously, I'm the facade of this organization, and I know that sometimes you see lots of memes on LinkedIn. That is to entertain you on one perspective, but my underlying theme is always to help you while in a fun way learn about complex things. That's how we've actually launched our educational startup. So we've now inwardly focused, meaning we are training ourselves, and we also use this platform to train our enterprise customers. That's why you don't see us talking a lot about live AI. But the goal is to actually learn first. If we are not able to learn first and teach our customers better, how do we go and start teaching the rest of the world? So it's a choice we made. I'm super excited to participate with Tanishta and Kwame, because the discussions, I can tell you guys, I mean, the discussions uh, that we are, and thank you so much for all your comments, by the way, Mattia. And I know some of you are not able to, we cannot display your name. but of course, it is Rose. You're here as well. So thank you so much, Rose. I know this is Rose from Dallas. You've seen me teach also in Dallas and Texas. We are very excited to actually bring these webinar series. So we start actually training our scientists into specific domains. We will also, over time, we will also introduce uh, uh, other energy domains such as electrification, electric batteries, solar panels, wind energy, energy management systems. So there's going to be a lot of exciting stuff coming, and everything that you're seeing in these videos and everything that we are talking about, you will get notebooks so you can actually also start playing with those things. So it's not going to be just a bunch of people talking about all the things that you have done. We will give you all the resources so you can also learn and do a wonderful job. Thank you very much. We love you all. I really appreciate that you came. This is our first webinar, and we hope to come back with a bang and go more into details. Keep watching our GitHub channel or repository, I should say, and we will keep adding more content, more fun stuff. Thanks very much, guys.
Thank you.
We
Thanks
love you guys.
everyone for joining.
Thank you.
Thank you.
Thank you, guys. Take care. Bye bye. Bye bye.
Bye.
Bye.